if you go through, and so we went through with at some cost for you, psychologically, we worked through this one here. We worked through this one here just now, right? And I told you what this one does, and here's Hack's law as well. So the story is that all these laws here, they have all these exponents that can be connected to each other, right? So there's this kind of weak fractal scaling for the mainstream length that just sort of sits by itself. This is usually just a bit greater than 1, if anything. It's pretty weak. And then we have Tokunaga's law here, 2 parameters. We can, if we want, connect them to the Horton parameters. And then here are Horton's laws, and then here are these bigger ones which don't have stream ordering built into them, but Hack's exponent, for example, we've just derived, it's connected to the Horton ratios, and then we'll just say H is, we'll just use H after that. And so as you see down here, it's just the fractal exponent D and Hack's exponent. So those things are just appearing over and over again. So all of these are tied together. So if you have one of these, you can derive the others. And this is a really great thing to be able to do with a system, right? Is to say, okay, we made all these observations. Many people have kind of attacked it in different ways and shown these kind of nice scalings and things. And eventually you come through at the end and you say, well, actually there are really only 2 things, parameters that describe this. This is a long effort, really, 60, 70 years, of course, and that's spanning the time that we figure out the satellite thing and start taking pictures and digitizing and build the web and all that sort of stuff, build the internet. It sort of spans have computers, spans an interesting time in history of science. But as I said, we don't really, I feel, have, we have all these connections, and they're all, it's all mathematical, it's all derived, right? We can say this, but we don't have a mechanism that everyone thinks is fine that says, oh, H is whatever.